guess you guys are going to get the top of my head for a little bit. The camera's set for when I stand, which would be my preferred working position 90% of the time, but I'm just going to chill out and try to do some reading here. Uh, this is our title card. Figured out a new way to try and do those. And kind of changed my whole workflow a little bit yesterday. The more I've studied this first playlist arc, about 100 episodes, is almost as much research about how to do a show as it is about building CRUD apps. A little side. And again, that's permaculture. You never do anything for one reason. If you have one reason, you're probably not being efficient. Ideally, you'd like to find 7 reasons for everything you do. So, here we are, doing what we do. There's our title card. I'll take that off the screen for now. And as far as I'm concerned, we probably won't even get... I'm thinking we can let this computer rest. But we won't. Yeah, we will. We'll power down for a minute. Let's do won't do a shutdown. We'll just do it. We'll do a sleep. Won't be that hard to get back if we need to. Okay. So now we're back on our Windows 10. Our title card. You know what? I can put that on the other side for no reason. And this is going to be our weekly template. We can come back to that. So really that gives us a pretty clean desktop to play with for the show anyways. Everything's kind of messy would be on the... It's swept over to the other monitor out of the way for a while, along with my face. So you get my voice and my desktop. How's that? What we really need to focus on is the book. And let's see. We'll grab a copy of the book from here. That should load us up a copy of the book. How's that look? Can we work with that? I'm going to have to sign in, I bet. No, maybe not. Okay, we got us in. Let's make sure we're in the right spot. We're just gonna start back at the beginning with chapter 7. Now we've got a little context. We've played with the code. We've seen the error message that are coming back. It says something about concurrently. Running concurrently, that was something that it's supposed to be doing. I remember it saying that in the text, but we've had our lab hours, so to speak. Now it's time to go back to theory, kind of catch up what compares to what and why. So, introduction to Angular. We got the passport working in chapter 6 material. So now we're going to try and get Angular to display our login. And it's catching up on the load somewhere in there. So, let's just work through this one step at a time. Let's figure out what's going on here. The last piece of the main puzzle. We're almost there. This is the last piece, guys. The last piece of the main puzzle is, of course, Angular. Back in 2009, while building their JSON as platform service, developers Misko Hiveri and Adam Abrons noticed that the common JavaScript libraries weren't enough. The nature of their rich web applications raised the need for a more structured framework that would reduce redundant work and keep the project code organized. Abandoning their original idea, they decided to focus on the development of their framework, naming it AngularJS, and releasing it under an open source license. The idea was to bridge the gap between JavaScript and HTML and help popularize single-page application development. In the years to come, AngularJS, now referred to as Angular, became one of the most popular frameworks in the JavaScript ecosystem, and it completely changed the front end development world. However, in the past few years, there were a few major paradigm shifts. So when the Google sponsored team decided to work on Angular's next version, they introduced a whole set of new ideas. In this chapter, we'll cover the following topics. So it could be in TypeScript. I don't know if I might not be installing TypeScript the way I'm supposed to. Or I might not be installing Angular. I don't know. There's something npm start. Alright. Understanding the building blocks of Angular 2, installing and configuring TypeScript in Angular 2, so it could be that. It could be configuring TypeScript. Creating and organizing the Angular 2 application. Utilizing Angular's component structure, implementing the authentication component. Next section, please. Check, please. And so that was another thing. When we read through these before, I don't think we check marked a lot of them. Yeah. Around the project setup, I quit checking them off because I felt like I was ready to play with the code. So there could easily be something in here we haven't read properly that's keeping us from getting this. And the code sample we're trying to run comes from the end of the chapter, so we can't try to run it properly. We can't expect it to run properly until we've made it through all the text in context. Okay, so now we're on introducing Angular 2. Introduction to TypeScript. Alright. Angular was a front-end JavaScript framework designed to build single-page applications using a model view controller-like architecture. The Angular approach was to extend the functionality of HTML using special attributes that bind JavaScript logic with HTML elements. Angular's JavaScript ability to extend HTML allowed cleaner DOM manipulation through client-side templating and two-way data binding that seamlessly synchronized between models and views. AngularJS also improved the application's code structure and testability using model view controller and dependency injection. Angular 1 was and still is a great framework, but it was built with the concepts of ES5 in mind, and with the huge improvements brought by the new ES5 specification coming up, the team had to rethink the entire approach, from Angular 1 to Angular 2. If you're already familiar with Angular 1, moving to Angular 2 might seem like a big step. However, the Angular team made sure to keep the good parts of Angular 1 while leveraging ES 2015's new capabilities and maintaining a clearer path toward an improved framework. Here is a quick summary of the changes made from Angular 1. I never really used Angular 1, so it's almost easier for me not to learn backwards. But basically they changed the syntax. Angular 2 relies on new ECMAScript specification, formerly known as ES6 and now renamed ES. So, however, the specification is still a work in progress, and browser support is still lacking. To overcome this issue, I wonder if we're using we're using a modern browser, but we are using it on 7. To overcome this, the Angular 2 team decided to use TypeScript. TypeScript. So this is a polyfill for the syntax of Angular 2. So maybe that's it. Maybe I need to install TypeScript to Node. TypeScript is a superset of ES 2015, which means that it allows you to write strongly typed ES 2015 code, which will later be compiled into ES5 or ES 2015 source depending on your needs and platform support. Angular 2 is pushing hard for TypeScript usage in their documentation and code examples, and so will we. Don't worry though, as vast and terrifying as TypeScript might seem, by the end of this chapter you'll be able to use it. Angular 1 introduced a modular architecture that required the usage of the Angular module custom method. However, ES 2015 introduced a built-in module system very similar to the one used in Node.js, so Angular 2 modules are much easier to create and use. Controllers. Angular 1 was all about controllers. In the first version of this book, this chapter was mainly focused on Angular 1 MVC approach. But in Angular 2, the basic building block is components. The shift also represents a bigger shift in the JavaScript ecosystem, especially regarding web components. Scopes. The famous scoped object is now obsolete. In Angular 2, the component module In Angular 2, the component model is cleaner and more readable. Generally, the introduction in classes in ES 2015 and its support in TypeScript allows better design patterns. Decorators. Decorators is a design feature implemented in TypeScript and is probably going to be implemented in ES 2016, now going to be called ES7. Decorators allow developers to annotate classes and members in order to add features or data while not extending the entity. Angular 2 relies on decorators to implement certain features, and you're going to deal with them later in this chapter. Dependency injection. Angular 1 used the dependency injection paradigm quite intensively. Angular 2 made dependency injection simpler and now supports multiple injectors instead of one. All of these features mark a new era for Angular and JavaScript in general, and it all starts with TypeScript. Booyah. 11 minutes in, we got 2 pages read. These are the big pages. Let's see. These are the ones we checked off already. So we're really just reviewing, trying to figure out, get some context here, figure out what's going on. This one's not too bad, actually. And it might be, with any luck, this is a introduction to TypeScript. With any luck, this is exactly what we've been missing. So, free your mind. The beginning of all knowledge is the assumption of ignorance. If you can assume you're ignorant, like you kind of, Rumsfeld? We do not know what we do not know. If you can embrace the fact that there are things that you do not understand, it makes it easier to find what you are looking for. So here we go. That's why I'm recording this. You know, some people think you just like don't understand what the workflow is, the process. And the process is learning the information, learning the technology, learning how all these gears fit together, learning the stack. TypeScript is a typed programming language created by Microsoft, which uses the object-oriented foundation of C#, Java, and now ES 2015. Code written in TypeScript is transpiled into JavaScript code either in ES3, ES5, or ES 2015, and can be run on any of the modern web browsers. It is also a superset of ES 2015, so basically any JavaScript code is valid TypeScript code. Any JavaScript code is valid TypeScript code. Not all TypeScript code is valid JavaScript. Yet. It's using a technology that's not been standardized, so they're using something to translate it until it is standardized. They're using a translator in between. Is that what I'm understanding? The idea behind this was to create a strongly typed programming language for big projects that will allow big teams to better communicate the interface between their software components. As derived from its name, TypeScript has an optional type system that allows developers to enforce limits on their code in order to have better clarity. Since a lot of the features in TypeScript were already implemented in ES 2015, we'll touch a few basic features that we'll need and didn't get in the current specifications. Since a lot of the features in TypeScript were already implemented in ES 2015, types are a major part of every programming language, including JavaScript. Unfortunately, static typing was not introduced in ES 2015, however. TypeScript support the basic JavaScript types, and also allows developers to create and use their own types. Basic types. Types can be JavaScript primitive types, as shown in the following code. Okay. Let first name be a string equal to John. Let last name be equal to Smith. Okay, the colon string, I guess, is what's making the difference. So you're setting the type right here, because you're already doing like variable name equals John, but now you're doing a colon equals the type. Yeah, these are all last name equals Smith. So that's not inherently a string, I guess. I'm not sure what the difference in the first two would be, but I doubt it's what's making our code not run. Here we got a colon. So the type, colon string, colon number, colon boolean. Moreover, TypeScript also allows you to work with arrays. These are numbers equal to, these names are an array equal to, an array, these names, okay, this is type. Type is an array of strings. Okay, that makes sense. Still not what I think we're caught on. Both ways are then transpiled into the familiar JavaScript array declaration, the AnyType. The AnyType represents any freeform JavaScript value. The value of any will go through a minimal static type checking by the transpiler. Okay, I remember seeing any in there. I kind of wondered about that. The any hit me about like this did the first time. When you see this as a keyword, seeing any as a keyword is like, what's any? What's an any? Is it different than an Audi? I just did not understand, but it's starting. That might make a connection there. The any type represents any freeform JavaScript value. The value of any will go through a minimal static type checking by the transpiler and will support all operations as a JavaScript value. All properties on an any value can be X. Oh, I passed our 25 mark. Mr. Eggman, are you sleeping on the job? Did you call in sick today? Mr. Eggman never clocked in today. Oh, that's live. Okay. I looked at the wrong time. We've been live for 33 minutes, but I didn't start recording until 17. So that's part of the new workflow. That's fine. Mr. Eggman's running. Mr. Eggman says, I'm here. Oh, I'm working. Mr. Eggman, don't take workman's comp. You fell off the shelf. Go horsing around. Alright, so the any type represents any freeform JavaScript value. The value of any will go through a minimal static type checking by the transpiler and will support all operations as a JavaScript value. All properties on an any value can be accessed, and any value can also be called as a function with an argument list. Actually, any is a superset, is a super type of all types. And whenever TypeScript cannot infer a type, the any type will be used. You'll be able to use the any type either explicitly or not. Okay, there it is. As far as type, it's the colon type. Okay, that kind of makes better sense now. And I'm not sure what gave it context that it didn't have before, I guess seeing the any, I don't know. It was like as TypeScript is about keeping the structure of your project, highly important parts of the language are interfaces. An interface allows you to shape your object and keep your code solid and clear. Classes can implement interfaces, which mean that they will have to conform to the properties or methods declared in the interface. Interfaces can also inherit from other interfaces, which means that their implementing classes will be able to implement the extended interfaces. An example TypeScript interface will look similar to this. Number, okay. Engine, Drive. Okay, so the engine's a string, the wheels are a number, so your schema is identifying types in the objects. Here we have an iVehicle interface with two properties and one method. An implementing class would look like this. Constructor wheels number, engine wheels number, engine string. Okay, that makes more sense now than it did before. This wheels equals wheels. So here it's setting the type, and then here it's setting the value of that type, of that infer that this. Okay, wheels number, because here it's a variable and here it's a type. It makes it almost so much more clear now. Still doesn't solve why we can't run 7, but we're getting there. We're working our way through this. Drive, console log driving. As you can see, the car class implements the iVehicle interface and follows the structure set by it. Note, interfaces are a powerful feature of TypeScript and are an important part of object-oriented programming. It is recommended that you continue reading about them here. It is recommended that you let me finish this page because I got 3 minutes to do it. Well, it's still in the proposal stage for the new ESC7, so keep it under your hat. Specifications. Angular 2 relies heavily on decorators. A decorator is a special kind of declaration that can be attached to various entities, such as classes, methods, or properties. Decorators provide developers with a reusable way to annotate and modify classes and members. A decorator uses the @decorator name form, where the decorator name parameter must be a function that will be called at runtime with the decorated entity. A simple decorator would look as follows. Function decorator target any. There's that any again. @decorator class my class. @decorator. So the is almost like it is a class. @decorator class my class. Class my class. Class my class. Class my class. Okay, I kind of understand that. At runtime, the decorator will be executed with the target parameter populated with the myClass constructor. The decorator will be executed with the target parameter populated with the myClass constructor. Moreover, the decorator can also have arguments as follows. Function decorator with arguments target any options object, return target object. Options object, target object. Up here you're setting the target, but here the options are being fed in and the target's being returned. Target object. Okay. Still think that's our solution, but I'm just trying to absorb what they're saying here. Type, some type. @decorator with args. Type, some type. Target object. This pattern is also known as a decorator factory. Decorators may seem a bit odd, but as soon as we dive into Angular 2, you'll begin to understand their robustness. Summary. TypeScript has been around for years and is being developed by a very strong team. This means that we've barely scratched the surface of its endless features and abilities. However, this introduction will provide us with the skills and knowledge required for diving into the great framework that Angular 2 is. Okay. we're hitting right at we're 10 seconds from 25 minutes, so we'll break the episode here. Okay, so as far as changing my workflow, we'll go ahead and let the stream flow, and then I can pull highlights out for each episode, and then I'll use the past broadcast and like 4 hour blocks of streaming to pull my 8 episodes out of. So we'll pull the highlights will be the episodes that get pulled out. So that being said, I'm going to go ahead and hit this. I'll show you what I'm talking about, just for reference sake. These are historical documentaries in a way. Just documenting the work. Here we go. Stop recording, and we'll let the streaming run. And I'm gonna take a quick break. Not long at all. Just get up and stretch my legs. I might come back and stand up for a bit. We'll read the next little chapter. 1 viewer, 885 views, 9 followers, 2455 on the bit rate. Alright. I like the new production setup. I switched the screens, and even when the server's sleeping, I think overall it's still a good setup to have it that way. That's the main monitor anyways. The whole reason I changed them was why? Because of where stuff pops up. Like, I wouldn't want to accidentally show you yeah, that. So that'll just be on the broadcast, and we can drop that out pretty quick. I just gotta pull the highlights out. And there's ways around that. I can go, here's the Dell. We're on the Dell. Now you can't see my Dell anymore. So now I can do the team viewer. See, now that's up on my screen. And I don't think you can see it anymore. Yeah, because you don't see the Dell. No matter what's on it, you don't see either one of the screens. You don't see the Dell. That's on the Dell now. I can show you the Dell. It's not on the Vizio either. So there's the Vizio. There's the Dell. Take both of those out. Here's our image. Look at that. I might use that one for a minute. We got a color source. We'll use that one for no. We'll use that for our Be Right Back episodes. What I mean by that is so there I'm standing up. There I'm standing up. Can you hear the music that's in my headphones? I'll do my sound check. Okay, now that I got these, I can kind of use them as I can start using these as stamp patterns on the editor at night. So after we'll do the broadcast in 4 hour blocks, and then I'll see the screenshot, and I'll know we can clip those out on the edit cuts. Hey, get back to work. What are you doing there? What are you doing there? I see you. Mr. Eggman says you're not on break. What do you think? Does the Sugar Soda want to sponsor our broadcast? Hire me to make a Coca-Cola app. Alright. I really just want to get 7 running. I don't know what's up, but Angular's a big step. If we don't get it working soon, we might have to just break into Angular by itself, just do like a sub list, just work on Angular for a day or something. Because I mean, that's the whole point of the stack. We're putting all these different technologies together. It does look like it's trying to do something. We're getting some feedback from the server. Alright, now we got a little practice and context, so we can get through this one in 25. Let's say 20, yeah, there he is, his little dot lines up, it's 25. Stop streaming, nope. Start recording. We had a viewer join during the break, but now that I'm back from break, they've dropped out. So, whatevs. Sorry I missed you. You're welcome to go to the archived views and stuff. Catch up. Or go read the book. You'd probably get ahead of me. The goal of Angular 2 is simple. Bring HTML and JavaScript together in a manageable and scalable way in order to build a client application. To do that, Angular 2 uses a component-based approach with supporting entities, such as services and directives being injected into the components at runtime. This approach may seem a bit odd at first, but it allows us to keep a clear separation of concerns and generally maintain a clearer project structure. In order to understand the basics of Angular 2, take a look at the following figure, which was a bit confusing last time. I had trouble getting through this. I mean, I get it, kinda. See, authentication service. So the data service goes over to the authentication service and then goes into the injector. The authentication component, data binding, event binding, authentication template, bundled directive, then back to the home component, or the home template, custom directive, bundled directive, custom directive. Okay, it does make a little more sense the second time through. Third time through, whatever this has been. Excuse me. The preceding figure represents a simplistic architecture for an Angular 2 application consisting of two components. The center entities are the components. Each component performs data binding and event handling with its template in order to present the user with an interactive UI. Services are created for any other tasks such as loading data, performing calculations, and so on. The services are then consumed by the components that delegate these tasks. Directives are the instructions for the rendering of the components' templates. In order to understand this better, let's dive in a little deeper. Angular 2 modules. Angular 2 applications are usually modular applications. This means that an Angular 2 application consists of multiple modules, and each one is a piece of code usually dedicated to a single task. In fact, the entire framework is built in a modular way that allows developers to import only the features they need. Fortunately, Angular 2 uses the ES 2015 module syntax we covered earlier. Our application will be built on custom modules as well, and a sample application module would look as follows. So you're going to import the Angular module, import the common module, import the router module, all from Angular's directories. Angular's, okay, those are directories. I mean, decorators. The @ sign makes those decorators, is what they were talking about a little bit higher in the text. And then import app component from app component, and then import app routes from app routes. Okay. Then the decorator Angular module imports common module, router module for route app routes. Okay, declarations app component, bootstrap app component, export class app module. Okay, that kind of makes sense. As you can see, we use the Angular module decorator to create the application module, which uses the application component and routes to bootstrap our application. To understand this better, let's take a look at the first and foremost building block of an Angular 2 application, the component. Angular 2 components. A component is the essential building block of an Angular 2 application. Its job is to control a dedicated part of a user interface, usually referred to as a view. Most applications will consist of at least one root application component and usually multiple components that control different views. Components are usually defined as a regular ES 2015 class with a component metadata. The component class is then exported as a module that can be imported and used in other parts of your application. A simple application component would be as follows. Okay, import component from Angular core, component selector main app, template. Okay, H1, I am an application component. Export class app component. Note how we import the app component decorator from the Angular core module library and then use it to define our component DOM selector and the template we want to use. In the end, we export a class called app component. Components are one side of the view management, and we have the template on the other side. Angular 2 templates. Templates are used by the components to render a component view. They are formed from a mix of basic HTML combined with Angular dedicated annotations, which tell the component how to render the final view. In the previous example, you can see that a simple template is passed directly to the app component class. However, you can also save your template in an external template file and change your component as follows. Import component from @Angular core @component selector main app template. That's the line that's different. The URL app template HTML. Export class app component. As you can see here, our current template is static. So in order to create more useful templates, it's time to discuss data binding. I really think, data binding is kind of it's a new level, so I can see why that's probably giving us problems with Chapter 7. One of Angular's greatest features giving me problems. Let's see, you one viewer that is watching this, why can't you not get past this? One of Angular's greatest features is its sophisticated data binding abilities. If you're used to working outside a framework, you know the nightmare that it is to manage data updates between the view and your data model. Luckily, Angular's data binding provides you with a straightforward way of managing the binding between your component class and the rendered view, interpolation binding. The simplest way of binding data from your component class to your template is called interpolation. An interpolation binds a value of the class property with your template using the double curly bracket syntax. A simple example of this mechanism will be as follows. Okay, what they're highlighting is the title being in double brackets. Note how we bind the title property of our app component class inside the template HTML property binding. Another example of one-way data binding would be property binding, which allows you to bind an HTML property value with a component property value or any other template expression. This is done using square brackets as follows. So the square brackets, the disabled, let's see. Okay, an element property, so the button's disabled. Or any other template expression. Okay, in this example, Angular will render the button as it's disabled since we set the isButtonDisabled property to true. IsButtonDisabled equals isButtonDisabled. Okay. Event binding. We're only at 10 minutes. All right, we're good. Just checking our time flow. Hey, I got my first comment live. Who's this? Bearbot Gaming. Bearbot Gaming. Oh hey. Cool. Let's. Back to work. Let's see, what was I done? We got there we go. Okay. Event binding. In order for your component to that's kind of cool to have a viewer. I'm glad to have somebody in the chat for once. Maybe you can figure out what I'm doing wrong and help me learn. In order for your component to respond to the DOM event generated from the view, Angular 2 provides you with the mechanism of event binding to bind a DOM event to a component method. All you have to do is set the event name inside your brackets as shown in the following example. Let's see. Okay, so the click is getting the show message. And a lot of this stuff is abstract. I don't think this is where I'm not getting 7 to run. I can say we now. I got somebody in the comments. We can't get 7 to run. We're team. We got somebody working us. Let's see. In this example, a click event of the view button will call the show message method inside our app component class. Two-way binding. Up until now, we've only discussed one-way data binding, where either the view calls a component function or the component changes the view. However, when dealing with user inputs, we'll need to be able to do two-way data binding in a seamless way. This can be done by adding the Angular model property to your input HTML element and binding it to a component property. To do that, we'll need to use a combination syntax of round and square brackets as shown in the following example. In this example, a user will see... wait a second. It's easy to just glance over the code. I want to read that again. Get focused. Up until now, we've only discussed one-way data binding. This can be done by adding the Angular model property to your HTML element. The Angular property, okay. So the Angular model, so the name is equal to the Angular model. Hello. Okay, so this name is coming from here. Okay, I get that. I just thought I was going to kind of glance over it for a second. In this example, a user will see a title element that will be updated live according to the input. The input binds the name property both ways, so every change to the input value will be updated to the app component class and rendered into the view. The Angular model property we used here is called a directive, so naturally it's time to discuss directives. It's the prime directive. Nope, it's the second Angular directive. Angular's basic operation is to transform our dynamic templates into views using a set of instructions that are usually directives. There are several types of directives, but the most basic and surprising one is the component. The @component director actually extends the @directive decorator by adding a template to it. Remember the selector property in previous examples. If you use the selector as a tag inside another component, it will render our component inside. But this is just one type of directive. The other would be our Angular model directive in the previous example. All in all, we have 3 types of directives. Attribute directives. Attribute directives change the behavior or appearance of a DOM element. We use these directives as HTML attributes on the given DOM element that we want to change. Angular 2 comes with several pre-built attribute directives, such as the following: Angular class, Angular style, Angular model. Class, style, model. Provides a way to bind singular or multiple classes to an element. Provides a way to bind singular or multiple inline styles to an element. Okay, I was going to say class and style seem similar, but creates a two. Okay, so the first two are one-way binding, right? Provides a way to bind singular or multiple classes to an element. Provides a way to bind singular or multiple inline styles to an element. Creates a two-way data binding over form elements. These are just a few examples, but you should keep in mind that you can and should write your own custom directives. Structural directives. Structural directives change our application's DOM layout by removing and adding DOM elements. Now we might be getting close to what we're hanging up on, because I think I am only loading like the load directive, if that makes sense, where it keeps saying loading. I think I'm just not getting the right directive to transpile it out of that. Structural directives. Structural directives change our application's DOM layout by removing and adding DOM elements. Angular 2 contains three major structural directives you should know about: Angular if, Angular for, and Angular switch. $10. We can get close in 10 minutes. Especially when we're not running the code. Angular if, Angular for, Angular switch. Provides a way to add or remove elements according to the condition. Provides a way to create copies of an element based. Provides a way to create copies of an element. Okay, because it's a for loop based on a list of objects. Okay. Angular switch provides a way to display a single element out of a list of elements based on a property value. All structural directives use a mechanism called the HTML5 template, which allows our DOM to hold an HTML template without rendering using the template tag. This has a consequence that we'll discuss when we use these directives. Component directives. As described previously, every component is basically a directive. For instance, let's say we have a component called sample component. I'm a component. At component. I'm a component. We can use it as a directive in our app component class as follows. Import component from Angular core. Import sample component from sample component. At component selector main app template sample component. Oh, there's the template. Okay, that makes more sense this time. Notice how we use the sample component tag and include our sample component module in the app component list of directives. To conclude, directives used to be a frightening concept for many Angular 1 developers. But now they're simple, easy to understand, and fun to use. Later in this book, we'll learn how to use the majority of the concepts presented in this section. Angular 2 services. Services are an essential part of Angular 2. They're basically just classes that a singular purpose or feature needs in the application. Since we want to keep our components clean and focused on the user experience, services come with pretty much everything else. For instance, any data management, logging, application configuration management, logging, application configuration, or otherwise a functionality that does not belong in a component will be implemented as a service. It is also worth noting that there is absolutely nothing special about Angular 2 services. They are just plain classes with a defined functionality. What is special about them is that we can make these services available for components using a mechanism called dependency injection. Angular 2 dependency injection. A dependency injection is a software design pattern popularized by a software engineer named Martin Fowler. I've heard that name before. Talks about pushing the, he's been on .NET Rocks a whole lot. He's like one of their main guests sometimes. Like he's on there, I think, more often than others, but he always has good things to say. He has interesting things to get you thinking about. Dependency injection is a software design pattern popularized by a software engineer named Martin Fowler. The main principle behind dependency injection is the inversion. I hope I'm not getting him mixed up now. I'll have to look him up so I can listen to his voice and be like, yeah, that's the guy. Or I might be wrong. The main principle behind dependency injection is the inversion of control in a software development architecture. To understand this better, let's take a look at the following notifier example. 5 minutes. If user role is absolutely equal to admin alert, you are admitted. Okay. Our notifier class creates an instance of user service And when the notify method is called, it alerts a different message based on the user role. Now this can work pretty well, but what happens when you want to test your notifier class? You will create a notifier instance in your test, but you won't be able to pass a mock user service object to test the different results of the notify method. Dependency injection solves this by moving the responsibility of creating the user service object to the creator of the notifier instance, whether it is another object or a test. This creator is often referred to as the injector. A revised injection dependent version of this example will be as follows. Use service. This use service notifier prototype notify function. Constant user equals this user service get user. If user role equals admin. Okay, kind of get that. Trying to speed up a little bit here so we can get the episode on time. We got 5 minutes, close to the bottom. Now, whenever you create an instance of the notifier class, the injector will be responsible for injecting a user service object into the constructor, making it possible to control the behavior of the notifier instance outside of its constructor, a design often described as the inversion of control, using dependency injection in Angular 2. And a lot of this is review. I'm just looking for new material that might change what I'm trying to accomplish, or give me a clue to what I'm missing. Using dependency injection in Angular 2. In Angular 2, dependency injection is used to inject services into components. Services are injected into the constructor function of the components as follows. So this should all be reviewed, but it's making more sense too the more context you have to put it in. Okay, import component from Angular core, import some service from users, service, some service. At component selector, some component, template hello services, providers, some service, export class, some component, user equals null, constructor, private, some service, this user, some service user. When Angular 2 creates an instance of a component class, it will first request an injector that will resolve the needed services to call the constructor function. If an injector contains a previous instance of the service, it will provide it, otherwise if an injector contains a previous instance of the service, it will provide it, otherwise the injector will create a new instance. To do that, you'll need to provide the component injector with the service provider. This is why we add the provider's property to the add component decorator. Furthermore, we can register providers at any level of our component tree, and a common pattern is to register providers at the root level when the application is being bootstrapped. So the same instance of the service will be available throughout the application component tree. Angular 2 routing. Our last topic before we set out to implement our application would be navigation and routing. Using web applications, users expect a certain type of URL routing. For this purpose, the Angular team created a module called the component router. The component router interprets the browser URL and then looks up its definition to find and load a component view. Supporting the modern browser's history API, the router will respond to any URL change, whether it's coming from the browser URL bar or a user interaction. So let's see how it works. Setup. It's a setup routes. So close. Since the Angular 2 team is focused on the modular approach, you'll need to load the router file separately, either from a local file or using a CDN. Furthermore, Content Distributor Network, CDN. I should remember what that stands for. Furthermore, you'll also have to set up the base href tag inside the head section of your main HTML file, but don't worry about it for now. We'll take care of these changes in the next section. Yeah, they've not told us really to change any code yet. They're just giving us the theory. So we'll work through it. It's coming. Every application will have one router, so when a URL navigation occurs, the router will look for the routing configuration made inside the application in order to determine which component to load in order to configure the application routing. Angular provides a special array class called routes, which includes a list mapping between URLs and components. An example for this mechanism is as follows. Import routes, router outlet. the component, I kind of just got an idea of not necessarily what's wrong, but where to look at to figure out what might be wrong. Figure out where to get a clue. Sometimes it takes you a while to figure out where to get a clue. Right at 25 minutes. Let's finish this page. We're so close. Router outlet. Let's see. Import routes from Angular router. Import home component from home component. Export constant home routes. Routes equals path component home component. Router outlet. The component router uses a hierarchical component structure, which means that every component decorated and loaded by the component router can have child paths configured so the route component is loaded and it renders its view in the main application tag. However, when child components are loaded, how and where are they going to be rendered? To solve this, the router module includes a directive called router outlet. To render your child components, all you have to do is include the router outlet directive inside your parent components template. An example component is as follows. Import component from Angular core, component selector, main app, template, application title, break, router outlet, application title, router outlet. Okay. Note that the router outlet tag will be replaced with your child components view router links. After we configure our application routes, we'll be able to navigate through our application either by changing the browser URL or using the router link directive to generate anchor tags pointing to a link inside our app. The router link directive uses an array of link parameters which the router will later resolve into a URL matching a component mapping. An example anchor with the router link directive will look like this. Summary. As we've progressed in this chapter, we've learned about TypeScript and Angular 2. Now we've covered everything we need in order to create an Angular application inside our main application. So let's start by setting up our project. Did I get this page checked off yet? Because I need to. Our Angular 2 architecture, then the project setup, managing authentication, and summary. Managing authentication, summary. Okay, next step. We'll do an episode break here, so I'm gonna stop recording. Can leave the streaming going, but I'll do the. I'm gonna turn off the Dell, and we'll put up the image, and then I'll know that's a set break. That'll help me on the editing tonight. And we've been on the air for an hour, so I should have. Is that 2 episodes then? Let's look at our show recordings. Maybe I did do 2. I guess I did. Time flies when you're having fun. Yeah, it looks like it. I did 1 this morning. Then I did a 1 in between that I didn't. Oh no, there's 1 that I just. I don't know. Did I? Maybe I didn't record this morning. I'll have to check the timestamps on them. I think I did 1 live, and then I recorded 1 offline. I think I did both. I think this is what I streamed this morning, and then I did 1 offline and deleted it maybe. Yeah, I think I've got 1 in the trash can, the recycle bin, that I'll probably delete. And then these are the 2 that I just did since we come back on. Yeah, 1318, 1353. So that'd be like 153. So that's 1 we're currently on. So I'm about to turn. That's the 1 we just turned off actually. It's not growing anymore. So that's 516, 48. So yeah, so we'll do 3 3-minute episodes so far. So that'll be good. Let's do it. Let's go ahead and work on our notes, or at least get ready. That's why I'll start the notes when we get back, because we've come through a lot of material here. I want to keep my show notes up to date. Open with brackets. We'll close these. It might be a better better version of it all coming together. Things the way they could be. every time I go on break, I get a secondary viewer, and then when I come back, he's gone. They're gone. But I left my title card up, so maybe that'll be the best thing for my set breaks, just to help keep organized. I'll close that. So the project setup. Forgot my drink, and I'm not recording. Dang. I just rushed myself back to work for no good reason. I was trying to get back before my viewer disappeared. But I'm going to go ahead and get me another glass of tea, and I'll put my title card back up since I did that. I like those for organizational purposes. And I need a little more control over my my area here. So I closed it. And it's on the other screen. It's more trouble than it's worth. I'm not supposed to let all this get in the way. Okay, we'll leave this over here. And then put it up. Let's see. We got Team Viewer, no. The book. And after the book, we've got the title card. That's all we need up there. Just like that. Alright. And then over here I want that, so I can see I don't have any viewers. And I want that so I can see my production looks like, so I know what my monitor's got up and my audio levels. Here, I'll turn my music up for the set break. And if I wanted to give it, just so I'll know the difference, now that I'm getting my workflow down, I can track these back better. See what difference that makes. So it brings it in here, but I'm assuming that turns it off in the video, in the stream. So I don't think it adds it to the mic mix. I think it's just me talking at the moment. So now I'm going to do back to the display. See, now it disappears. But I don't think you can hear the music at all. But whatevs. That's what it's doing. So I'll put the music back where I think you can hear it, which is here. See, now that's up. See, that's what's up. Okay, I'm happy with that. No, did that wrong. Let's try again. There. Okay, I can see how I'm gonna have to do it. There. Okay, let's keep pushing forward here. I try not to make okay the first thing I say when I come back to there every time. But luckily I haven't pushed the record button yet, and nobody's watching either, and I get to edit this to where I want to. So, here we go. There's Mr. Eggman. We'll set him to 25 minutes, and we'll hit our start recording button. Here's our title card, Chapter 7, Episode 55. The project setup. You know what? It's not available. I'll just try turning the music down a little bit. It's in my headset anyways. So it still sounds the same to me. It'll be good. It still sounds the same to me, but it should be turned down for you guys to hear me better. And my mic's as loud as I know how to get it turned up. Well, I keep looking for things to boost it, because I know I talk soft, I mumble or whatever, but we'll try and get through this. Try and keep myself on my mark. I got one little spot where I fall right in front of the webcam. Alright. In order to use Angular in our project, we'll need to install both TypeScript and Angular. We'll need to use the TypeScript transpiler to convert our TypeScript files into valid ES5 or ES6 JavaScript files. Furthermore, since Angular is a front-end framework, installing it requires the inclusion of JavaScript files in the main page of your application. This can be done in various ways, but the easiest one would be to download the files you need and store them in the public folder. Another approach is to use Angular CDN and load the files directly from the CDN server. While these two approaches are simple and easy to understand, they both have a strong flaw. Loading a single third-party JavaScript file is readable and direct, but what happens when you start adding more vendor libraries to your project? More importantly, how can you manage your dependencies versions? The answer to all these questions is Node Package Manager. Node Package Manager will allow us to install all of our dependencies and run the transcript transpiler while we develop our application. In order to do that, you'll need to change your package.json file as follows, which I think this should be done. Like, that's the code that he's given us to work with. So I will bookmark this as a place we can go back and look at post install. Looks like typing's install, but I mean the code that he's given us as samples all comes from the end of the chapter, so for the most part all this is done. In our new package.json file, we did a few things. First, we added our project's Angular dependencies, including a few supportive libraries. Will provide us with some ES6 polyfills, reflect metadata, reactive framework we'll use later. This will help with loading our application modules. This allows the creation of different execution context zones and is used by the Angular library. Concurrently, this will allow us to run both the TypeScript and transpiler and our server concurrently. Both the transpiler and our server concurrently. Okay. Typings. This will help us with downloading predefined TypeScript definitions to our external libraries. Up here, all this Angular dependencies. Okay, but still, all that should be in there now. We can, if we really can't find it, we'll go look at all that. But I think it's going to slow us down. We're just going to say it's there. At the top, we added a scripts property where we define different scripts we would like npm to run for us. For instance, we have a script that installs our typings for third-party libraries, another one that runs the TypeScript compiler called TypeScript compiler, a script called app that we use to run our node server, and one called start to run both of these scripts together using the concurrency tool. Next, we're going to configure the way we want the TypeScript compiler to run. Configuring TypeScript. In order to configure the way TypeScript works, we'll need to add a new file called to our application's root folder. In your new file, paste the following JSON. Again, this should be done. Configuring TypeScript. In order to configure the way TypeScript works, we'll need to add a new file to our application root folder. In your new file, paste the following JSON. In our TypeScript configure JSON file, we configured the TypeScript compiler to compile our TypeScript code into ES5 code, compile our modules into a system module pattern, use Node for module resolution, generate source maps, include decorators and emit their metadata, keep comments, cancel the error for any implicit declarations, not include the Node modules folder and typings files. You know what? I may have just thought of something. I'm telling it to, on the git ignore, I'm telling it to include Node in the git ignore for no reason. And I probably shouldn't do that. When we run our application, the TypeScript will use the TypeScript configuration JSON configuration file by default. Next, you'll need to add a new file called typingsJSON to your application root folder. In your new file, paste the following JSON. As you can see, we've added all third-party libraries we need in order for the TypeScript transpiler to compile our code properly. Once you're done, go ahead and install your new dependencies. npm install. Okay, I think we're using this. Let's go look. Let's do it on the other screen. It'll be easier for everybody. Hey, our viewers are back. Hey, viewers back. Hello, whoever's watching. I can't see anymore. I'm using your screen to go to GitHub. Not your screen, but the screen I would see you on. That's got my Twitch feedback for dashboard and stuff. But it says we're at 2 viewers. I always assume the first one's me watching myself. Even though it's on the dashboard, I think it still counts. It gets filtered out by the end of the day. But it gets counted in the short term for live stuff. What did I come over here to look at? It's the steps. Yeah, npm install. So I've already got that one. We've got the npm install in our steps. Maybe I can add this to that window. Yeah, I was just making sure what we got. npm install is there. I was just on it. There. So that makes it to our instructions. As you can see, we've added all third-party libraries we need in order for the TypeScript transpiler to compile our code properly. Once you're done, go ahead and install your new dependencies. All the packages we need will be installed along with external type definitions we'll need in order to support... Oh, let me get this back. So your full screen. And your production. Okay. All the packages we need will be installed along with external type definitions we'll need in order to support the TypeScript compiling. Now that we have installed our packages and configured our TypeScript implementation, it is time to set up Angular. Note, it is recommended that you continue reading about typings at the official documentation. Configuring Express. To start using Angular, you will need to include the new JavaScript library files in our main embedded JavaScript view. So we will use the app views index file as the main application page. However, npm installed all our dependencies in the node modules folder, which is not accessible to our client side. To solve this issue, we'll have to change our config express.js file as follows. I really feel like I want to go back and change the GitHub repository now. I feel like I shouldn't have set the git ignore for Node. The book never told me to do that, and that might be blocking some of this stuff. I don't know why I was getting experimental and there wasn't a reason to do that. A major change here involves the creation of a library static route that directs our node modules folder. While we were here, we also switched the order of the routes user and index routes. This will come in handy when we start dealing with Angular's routing mechanism in this regard. There is one more thing we have to do, and that is making sure our Express application always returns the main application view when receiving routes that are not defined. This is for the case where the browser's initial request is made using a URL that was generated by the Angular router and is not supported by our Express configuration. To do this, go back to AppRoutes index server routes.js file and change it as follows. Again, he would have done this before sharing the files. Now that we have configured TypeScript and Express, it is time to set up Angular, but before we do that, let's talk a bit about our application structure, restructuring the application. As you might remember from Chapter 3, building an Express web application, your application structure depends on the complexity of your application. We previously decided to use the horizontal approach for the main application. However, as we stated earlier, main applications can be constructed in various ways, and an Angular application structure is a different topic, which is often discussed by the community and the Angular development team. There are many doctrines for different purposes, some of which are a bit more complicated, while others offer a simpler approach. In this section, we'll introduce a recommended structure. With the move from Angular 1 to Angular 2, this discussion is now even more complicated. For us, the easiest approach would be to start by using the public folder of our Express application as the root folder for the Angular application, so that every file is available statically. There are several options to structure your application according to its complexity. A simple application can have a horizontal structure where entities are arranged in folders according to their type, and a main application file is placed at the root folder of the application. An example application structure of this kind can be seen in the following screenshot. I'll leave that up for a second. I'll take a sip anyways. Oh, we lost our viewer. Goodbye, good viewer. Sorry, I know this has got to be the most boring show, especially if it's not like your cup of tea to study this stuff. And if it is your cup of tea to study this stuff, there's going to be more efficient videos to watch. Like, people that have already studied it are going to condense it better. So, predominantly the show is about me documenting my work. But, that being said, the right viewer will find it useful. There will be a feedback loop eventually. Down my cup. I'll go a few minutes over. about that. I usually try and keep my cup handy because all that reading, I dry my mouth out quick, kind of thing. Start just tripping over my own tongue. I'm usually a quiet person, I think. I don't really vocalize a lot, so to be reading a book out loud, it's kind of a. I don't know if it's necessarily useful or productive. I may just do some silent reading at some points. I'm a slow reader anyway, so if I just shut up and let the reader read along, or the viewer read along, we might be more productive. I wonder if there's like that one guy out there that can't read but would make an awesome programmer if he just had somebody to read the books to him. Excuse me. Okay. I mean, this is all review. Kind of went through this the other day. It's the difference between horizontal and vertical architecture. It's all we're reviewing here. Nothing that would keep it from loading like it is. I don't know why it's getting stuck on that load screen. Is all we're really reviewing for. If we can get the code to run, we'll get out of this chapter. Again, that code should be in there. Again, should be in the codes. See, and then just npm start. That's the only two commands. We've went through that whole chapter, and it's only given us those two commands. And we've got both of those in the, that's why I brought it over here. npm install, npm start. We've done both of those. But, like I said, so we've got 5 minutes left in the episode. I'm going to try to do a new repository. We'll check this chapter off. Let's make sure we've read all this. see here, if it's just saying the header tag hello world, we're getting that. I want to make sure we got a clean repository on GitHub. So that being said, chapter 7. I really just want the readme file off of this for now. Everything else I'm going to delete. But I thought you could get just like a one file out. I'm basically going to comment this one out. Is my intention with the backslash. I don't know if it'll work right. Markdown. I'll take that to do something with it in brackets. Do file new. Make this make a new, make this a template if we have to. File, save as, put it on the desktop for now, and